You had a dream last night. You know you did. You might even remember fragments of it right now. A place, a person, a feeling you can't quite name. But within the next few minutes, it will be gone. Not faded. Gone. And no matter how hard you try to hold on to it, the harder you reach, the faster it disappears. Most people assume the answer is obvious. Dreams aren't real, so the brain doesn't bother saving them. But that's not what's happening. And the real reason is far stranger than you'd expect. Because your brain isn't failing to record your dreams, it's actively erasing them. On purpose. And the mechanism it uses to do that is the same one that keeps you sane. To understand why, you need to understand what a dream actually is, not philosophically, neurologically. When you fall asleep, your brain doesn't shut down. It shifts. Within about 90 minutes, you enter a stage called REM sleep, rapid eye movement. And during REM, something extraordinary happens. Your brain becomes almost as active as when you're fully awake. The visual cortex fires. The emotional centers light up. The motor cortex activates. Though your body is deliberately paralyzed so you don't act out what you're experiencing. In almost every measurable way, dreaming looks like living. Except for one region. The prefrontal cortex, the part of your brain responsible for logic, self-awareness, and critical thinking, goes almost completely quiet. That's why in dreams, you accept the impossible. You fly. You breathe underwater. You're back in a school you haven't seen in 20 years. And somehow, that makes perfect sense. The part of your brain that would say this isn't real, isn't there. And that matters enormously for what happens next. In 2011, a neuroscientist named Cristina Marzano at the University of Rome ran a study that changed how researchers think about dream memory. She tracked the brain waves of sleeping subjects and asked them to report their dreams immediately upon waking. What she found was precise. The people who remembered their dreams most clearly showed a specific pattern of brain activity just before waking. A surge in theta waves in the frontal lobe. Theta waves are associated with memory encoding. The people who remembered nothing showed no such surge. In other words, dream memory isn't random. It isn't about how vivid the dream was. It's about whether your brain switched into memory recording mode at the exact moment you woke up. And most of the time, it doesn't. Here's why. Memory consolidation, the process of moving an experience from short-term to long-term storage, requires a neurochemical called norepinephrine. Think of norepinephrine as the brain's save signal. When something happens that matters, norepinephrine spikes. It tags the experience. It tells the hippocampus, keep this. During the day, norepinephrine is constantly flowing. Every meaningful experience gets flagged and filed. But during REM sleep, norepinephrine production drops to almost zero. The brain essentially turns off the save function. Completely. Researchers at Harvard Medical School have proposed that this is deliberate, not a malfunction, a feature. Without norepinephrine, the brain can process emotional experiences, replay them, reframe them, extract meaning from them, without permanently cementing the raw emotional weight of the experience. You can revisit a fear in a dream without making the fear stronger. You can process grief without deepening the wound. Dreams, under this theory, are the brain's emotional editing suite. And to edit freely, you have to be able to delete. But there's another layer, and this one is structural. The hippocampus, the same curved structure that forms your waking memories, is still active during REM sleep. It's running. But the connection between the hippocampus and the prefrontal cortex, the pathway that takes a short-term experience and routes it into permanent storage, is functionally severed during sleep. Not broken, deliberately disconnected. Think of it like a conveyor belt in a factory. The belt is moving, but the chute at the end, the one that sends things to the warehouse, is closed. Whatever gets made on that belt during the night stays on the belt. And the moment you wake up, the belt resets. Gone. So why do some dreams stick? Why do some people wake up with vivid, detailed recall, while others can barely remember a single image? The answer comes from a neuroscientist named Perrine Ruby at the Lyon Neuroscience Research Center in France. In 2014, Ruby ran brain scans on two groups of people: high dream recallers, people who regularly remembered their dreams, and low dream recallers, people who almost never did. The difference wasn't in what happened during sleep. It was in what happened during brief moments of waking up. High dream recallers woke up more often during the night, sometimes for just a few seconds. Those micro-awakenings were enough for the brain to briefly switch back on the memory encoding system, just long enough to capture a fragment. Low dream recallers slept more solidly. No interruption, no window, no save. Which means the people who remember their dreams most vividly aren't better dreamers. They're lighter sleepers. And the people who wake up remembering nothing may actually be sleeping better. But here's where it gets genuinely strange, because it's not just about whether memories form. It's about what happens in the first seconds after you wake up. In 2017, researchers at the University of Adelaide in Australia studied what they called the dream fading window. They found that dream recall drops catastrophically within the first 2 minutes of waking, not gradually. Catastrophically. A dream that feels clear and vivid at the moment of waking is typically 50% gone within 5 minutes, and within 10 minutes, 90% of it has vanished. The trigger for this collapse is almost always the same thing: distraction. The moment your brain receives any new input after waking, a sound, a thought, a glance at your phone, the fragile, half-formed dream trace is overwritten because the same memory systems that would have saved the dream are now being used to process what's happening right now. Your brain doesn't multitask. It chooses, and it always chooses the present over the past. This leads to one of the more counterintuitive findings in sleep research. The best way to remember a dream is to do nothing. Don't move. Don't open your eyes. Don't reach for your phone. Just lie still and let the dream surface on its own. Researchers call this sleep inertia recall, the transition state between sleep and waking, lasting roughly 30 to 60 seconds, is the only window where the dreaming brain and the waking brain are briefly running simultaneously. It's the only moment where what happened in the night can be handed off to the day. Miss that window, and it's gone. Every time. Now here's the question most people don't think to ask. Why would the brain work this way at all? Why build an elaborate system of nightly experience, vivid enough to feel completely real, and then erase it? What's the point of a memory that's designed to disappear? The leading theory, developed by psychiatrist and dream researcher Matthew Walker at UC Berkeley, is that dreams serve a specific emotional function. Walker calls it overnight therapy. During REM sleep, with norepinephrine suppressed, the brain replays emotional experiences from your waking life. But it replays them in a neurochemical environment that strips out the stress. You can revisit the conversation that hurt you, the situation that scared you, the loss that broke something, but without the cortisol, without the norepinephrine. The emotional charge gradually decreases. You wake up having processed something you couldn't process while awake. And crucially, you don't remember doing it. Because if you did, if every disturbing dream left a vivid, permanent memory, sleep would stop being restorative. It would become another source of trauma. The forgetting isn't a flaw in the system. It is the system. There's one more piece, and it connects dreams to something much larger than sleep. In 2019, neuroscientist Giulio Tononi at the University of Wisconsin published a theory called synaptic homeostasis. The idea is this. During the day, as you learn and experience things, your synapses, the connections between neurons, grow stronger. More information, more connections, more weight. By the end of a waking day, your brain is literally heavier with experience, not metaphorically. The synaptic load is measurably higher. Sleep, Tononi argues, is when the brain resets that load. Weak, unimportant connections are pruned away. The brain clears space for tomorrow. Dreams, under this theory, are the byproduct of that pruning. The noise of the brain sorting through what to keep and what to delete. Not the main event, the exhaust. Which means when you dream, you aren't watching a story your brain is telling you. You're watching your brain do its housekeeping. And the reason you can't remember it is the same reason you don't remember your own digestive process. It wasn't meant for you to see. So here is what actually happened to your dream last night. Your hippocampus generated a flood of imagery and emotion, but with norepinephrine shut off, nothing was flagged for saving. The pathway to long-term memory was closed. You may have woken briefly, just long enough to catch a fragment, but the moment the first stimulus reached you, a sound, a thought, a notification, the window closed, and the dream dissolved. Not because it wasn't vivid enough, not because your memory is weak, but because your brain spent the night doing something far more important than remembering. It was processing your pain. It was clearing your mental load. It was preparing you to face tomorrow without the full weight of yesterday. And it did all of that, invisibly, quietly, without leaving a trace. Every person you have ever met woke up this morning having lived through an entire world that no longer exists. A world built overnight just for them, and gone before breakfast. The question isn't why you can't remember your dreams. The question is, what does it mean that your mind works hardest in the hours when you're least aware of it? And what else is it doing that you'll never know about?